Assalamualaikum and good morning, everyone. Okay, so today we will discuss exercise from last week topic, which is about how to find eigenvalues and eigenvectors. So actually we will discuss exercise 3 and also exercise number 4. So basically they are the same question, okay? But question exercise 4 requires you to diagonalize the matrix. Okay, so let's let's try to do this. So diagonalize the tensor below into D equals P inverse times S times P, and then find S power of 8. Okay, so let's diagonalize tensor S. So to diagonalize tensor S, we need to find eigenvalues and eigenvectors. Okay, so to find eigenvalues, we need to use the determinant, the concept of determinant of this one. And then we get then you can expand this to get the determinant. Then further expand this equation. So I hope I'm doing this correct. Then after you get this equation, then you can find the factors, meaning find the lambda when this equation equals 0. Okay, so you can use calculator to calculate. Okay, Salah tu. Okay, we can check using symbol lab. Okay, so you can factorize using calculator. So you will end up with 3 eigenvalues. Okay, so these are the eigenvalues. Then you can find the eigenvectors from each of these eigenvalues. Okay, so we start with lambda equals 2 and then substitute back into this equation. Okay, so basically you substitute lambda equals 2 into this equation. Okay, so n is our eigenvalues. Okay, so when lambda equals 2, so we get okay, then you can expand this by using matrix multiplication. So this become 0, 2 and 0 here. So you get n1 equals 0, n1 plus 2 n2 plus n3 equals 0, and then n2, and then another one is n2 equals 0. So here you get n2 equals 0, then we only left with this middle equation. So we need to find n1 and n3. So here from the middle equation, we know that n2 equals 0, so we get n1 plus n3 equals 0. So you can choose any value of n1 or n3 to satisfy this equation. Okay, so I'm choosing the simplest one, so n1 equals 1, then n3 equals minus 1. Okay, so you just choose anything to satisfy this equation. So the first eigenvalue, eigenvectors, is 1, 0, minus 1. Okay, so this is the first eigenvector. So now let's try find the second eigenvector when lambda equals 3 plus square root 3. So similar step, just substitute into the into this equation here. Okay, and then expand. So we need to solve this simultaneously because there are three equations. So this is a bit tricky, okay, to solve this. So you need to use knowledge from maybe numerical method, okay? So let's simplify first. I think you can use calculator, but let me see. Okay, kita guna simbol lab. Okay, so this is the first eigenvector that we get. So it's similar, but they choose n1 equals minus 1, okay, n3 equals 1. Okay, so soalan ni susah sebab dia ada square root kat sini. Tapi dalam exam tak adalah square root. Exam punya straightforward, okay. So let's look at the second eigenvector. So let's say we choose n1 equals 1. and n3 equals 1. So you can choose any value. So let's say n equals 1. So from n equals 1, then if n1 equals 1, then n2 equals 0. So you cannot have one more 0 here because this eigenvector is already 0 at n2. Okay, so you cannot have n2 0 because later on you will get the same eigenvector with the first one. So we hold on n2. So we take n3. So n3. Okay, so we get n2 equals 1 plus square root 3. Okay, so the way you choose is that you can choose something similar to the one above. Okay, but maybe later on I will show you. I will give you one more example for this. Okay. So second eigenvector is then we find the third eigenvector. Okay, so similar step. So expand this. Okay, then from here we choose again n1 equals 1. Okay, you can choose any value. I think n1 equals 0 also okay, but if you choose n1 equals 0, then n2 will be 0, then n3 will be 0 as well. So choose the smallest value possible. So I choose 1. Okay, so if you choose -1, also okay. So 1 is easier because it doesn't involve any negative value. So when choose n1 equals 1, then n2 equals So third eigenvector. Okay, so this is your eigenvalue and eigenvector. Later you can try again. Okay. Okay, so then the question asks you to find um, to diagonalize the matrix D, P inverse times S times P. So to get vector D, matrix D, you just arrange the eigenvalues on the diagonal element of D. So D equals P minus 1 SP. So D is the diagonal element with eigenvalues. So 2, 0, 0, 0. Boleh ingat 3 minus square root 3. 3 plus square root 3. Okay, so this is the matrix D. And then matrix P, you just arrange the eigenvectors. So eigenvector number 1 is this 1, 0, minus 1. So if this is value number 2, eigenvalue 2, then this column must be the eigenvectors correspond to this eigenvalue. Then second one, 3 plus square root 3 is this eigenvector. And then lastly is this eigenvector. Okay, so you get matrix D and P. Okay, then you can find the inverse of P using calculator. So please, if let's say your exam is face to face, please use your calculator to find the inverse. Okay, don't calculate manually. Okay, then the question asks you to find S power of 8. So we know that D equals P minus 1 S times P. So rearrange this, you get S equals P times D times P minus 1. So basically you multiply with P here to cancel out, to make sure this becomes identity, and then times P inverse in the front to get identity. So when you multiply this, then you multiply on the left hand side as well. Okay, so S power of 8, basically you power this 8 times. So you get okay, 8 kali. Okay, so you end up with P times D times D, so 8 kali. So you would get P p d power of 8 p minus 1. So your p is this matrix. So S8 equals p d8 p minus 1. So if D is power of 8, so you just power all of the elements because it is diagonal matrix. So this will become 2 power of 8, 256. Okay, then you can multiply this using calculator. Okay, guna simbol lab pun boleh. Kalau exam online. Okay, any question? Maybe later I will give you one more exercise, then you can try do it on your own. Okay. Okay, so if you have no question, then we continue with lecture 2C today. Okay, so we have learned about vector and tensor, and something that some of the things that you have learned before, some are new. So today we will look at how to apply calculus like differentiation, integration on vectors and also on matrix. So at the end of this lecture, you will be able to understand the basic concept of calculus of tensors and perform calculus operation on tensors. So all of the vectors and tensor that we have seen so far contains constant elements like constant values, numbers. So in this topic, we are going to look at vectors and tensors that have elements as a function of some variable, maybe in time or space. So let's review some of the calculus that you have learned. So let's say given a one variable function, fx equals x squared. So if you want to find f prime, you just differentiate this, becomes 2 times x. Then if you want to find f double prime, you get f double prime equals 2. Okay. So this is normal derivatives that you have learned. So in this topic, we are going to introduce you the partial derivative Okay, so partial derivative is usually used when you have function of more than one variable. So for example, f is a function of x and y. Okay, x and y at the same time. So for example, f equals x squared plus y cubed. So let's say you want to find f prime of x. So you differentiate f with respect to x. So we treat y as a constant value. So f prime of x. So you just differentiate the x squared. You get 2 times x. So we treat y as a constant. So differentiate a constant, you get 0. So 2x plus 0. So you get 2x. So if you want to find f prime of y, so we treat x a constant as a constant. So f prime of y, so we treat x as a constant. So differentiate constant, you get 0 plus. So this has a y here. So you get 3y squared. Okay, so look at what kind of differentiation you want. F prime of what? Then treat the other variables as a constant. So let's look at a different example. So sometimes we use this symbol, nombor 6 terbalik, mirror image of number 6. Ataupun I call this siput, okay? Or del, okay? Del siput. To represent the partial derivative. So let's say you have function of f, x, y, and z equals x power of 4 minus 3xyz. So you want to find del f, del x. So meaning that you want to find f prime of x. Okay, so you differentiate x only and treat the other variable as constant. So what we can do is look at the first equation, the first function, x power of 4. So this has x. So differentiate this, you get 4x cubed. And then look at the second one, you get minus 3xyz. So you have x here, but there are two more variables, y and z. So we can assume this y and z as a constant. So it's like 3yz times x. So when you differentiate this, you get 3yz. Differentiate x, you get 1. So you end up 3yz. Okay, similarly, if you want to find del f, del y, or f prime of y, so you differentiate only y and treat the other variables as constant. So the first one doesn't have any y, so this whole thing is a constant, so you get 0 minus 3xyz. So similarly, 3xyz, you will get 3xz times y. So these are constants. So differentiate this, you get 3xz. Okay, so minus. Similar to the last one, if you want to find f prime of z, so the first one has no z, so this whole thing become constant. And then the second one, minus 3xyz, so you just assume 3xy as a constant, while z is the variable you want to differentiate, so you get negative 3xy. Okay, so that's all for partial derivative. I hope you understand this, because this will be used a lot in next week lecture. Okay, so let's do this exercise. So given f of x and y, equals 2x squared plus 3xy plus 6x minus 7y. So question A, find del f del x. Okay, so del f del x, you assume you want to differentiate x while assuming other variables as constant. So look at the first one, you get 4x plus this one, y is the constant, so 3y x. Differentiate that, you get 3y plus 6x, so you get 6. And then lastly, minus 7y, there is no x, then you just get 0 for this term. So del f del x, you get 4x plus 3y plus 6. So second question, del f del y. So the first one, 2x squared, you have no y, so you get 0, plus 3xy, so you get y here, so you treat 3x as a constant, so you get 3x, plus 6x, again there is no y, and then minus 7y, so you get minus 7. Okay, then find del square f del y del x and del square of the first equation of the first of question equation A. So del y of del f del x. So differentiate this with respect to y. So look at this equation. For x, there is no y, you get 0. Plus 3y, you have y here, so you can differentiate, you get 3. Plus 6, so this is a constant, differentiate constant, you get 0. Okay, so the first part here, you get equals 3. So the second part, similarly, it's the del x of del f del y. So meaning that you differentiate with respect to x of the second equation here, or equation of B. Okay, so differentiate with respect to x. So here 3x. So you have x here. You differentiate, you get 3. Minus 7 is a constant. Differentiate with respect to x, you get 0. So what relationship you can deduce? Basically, del square f del y del x equals del square f del x del y. Okay, so this is an important relationship. Okay, if you differentiate a function, it doesn't matter if you differentiate y first or x first, you will get the same answer. Okay, 3 or 3. Okay, so I hope you understand partial derivative. So now let's look at the application of partial derivative in vector and also tensor. So in vector and tensor, we have the term del operator. Okay, so del operator is represented by this symbol triangle. So triangle. So this triangle, it's a vector. You have del x, del over del x times vector e1 or vector I plus del y times e2 or vector j plus del z e3 or vector k. Okay, so del is a vector. So if you still remember lecture on vector, you have dot product, cross product, So del can be dot product with a vector and can be cross product with another vector. Okay, so we will look at how we can apply that. Okay, so the first thing that we can use from the del operator is what we call the gradient. Okay, gradient of a scalar. So when you calculate the gradient of a scalar function, it will produce a vector. So let's say if you want to find del f is a scalar value, a value or a number or a function, scalar function. So basically you differentiate del f over del x1. So this is in the form of vectors. So you get del f del x1 e1 plus del f del x2 e2 plus del f del x3 e3. So this is important if you want to calculate gradient, okay, especially in finite element method. Okay, so when you want to calculate gradient, it is represented by this figure. Okay, so the arrow here represent the change of gradient. Okay, so the color, the black and white color represent how the gradient changes according to the direction of this vector. So when you differentiate f, you get this vector, the blue colored vector. So let's look at an example. So given a scalar function f of x, y, and z equals 2x plus 3y squared minus sine of z. So determine the gradient. Okay, so first you can find the formula of gradient, del of f, and then you get del f del x e1, del f del y e2, plus del f del z e3. So firstly, let's differentiate del f del x. Okay, del f with respect to x. So here we have x, and then this is 3y squared. So this is a constant minus sine z. So this is also constant. So becomes 0. So you only get 2. So you get 2 times e1. And the second one, if you have del f del y e2, so you differentiate f with respect to y. So again, 2x is a constant. 3y squared, you get 6y minus sine z. So sine z, it's a constant, a 0. And then lastly, you have differentiation of f with respect to z. So again, 2x is a constant, 3y squared a constant because there is no z, minus sine z. So here you get cosine z, okay, minus, okay, so you get cosine z times e3. Okay, so just remember the formula. So for e1, you differentiate with respect to x, e2 with respect to y, e3 with respect to z, or x1, x2, x3. Okay. Sometimes in question in exam, I use x1, x2, x3. Sometimes x, y, z. Okay, so it's the same thing. Okay. So gradient also can be applied on a vector. So just now it's a gradient of a scalar. Now we can apply gradient on a vector. So let's say if you have a vector f equals f1 e1 plus f2 e2 plus f3 e3. So if you apply gradient to this vector, it will produce a tensor. Okay, so this is the tensor. Ni hafal je lah kalau keluar. Tak keluar kot. Okay, so let's try differentiate, find the gradient of this motion. Okay, so let's say a motion. So this is a symbol chi. Okay, chi. So chi equals 3x3 comma minus x1, comma minus 2x2. So when you have comma here, it's a vector. Okay, so find the gradient of the motion. So you will produce a tensor. So tak ingat formula, tengok dulu. 1, 2, 3. 1, 2, 3, okay. So first you differentiate. Better tulis dulu kot. Okay, so let's do this. So first one, del x1, which is this one, over del x1. So 3x3, there is no x1. So you can treat x3 as a constant. So differentiate a constant, you get 0. Second one, del x1, del chi1. So chi1 is the first element here with respect to del x2. So in the first element, you only have x3, there is no x2. So to differentiate with respect to x2, you assume the other vectors or the other variables as constant. So 3x3 is a constant. Differentiate with x2, you get 0. So similarly, lastly, del x1 over del x3, del chi1 over del x3. So here, 3x3. So here is a x3. So differentiate with respect to x3, you get 3. Okay, repeat the process. So here, x1 of chi2. So this is chi2. So you get minus 1 over x2. There is no x2. 0 over x3. There is no x3. You get 0. And then repeat for the last row. For chi3, this is chi3 over x1. There is no x1 over x2. Here you have minus 2x2. So differentiate with respect to x2, you get minus 2. And lastly, differentiate with respect to x3. There is no x3 here, so you get 0. So this is the gradient of this motion. Okay, so try to do it yourself later, and then you will see how to get this answer. Okay, so we will apply this a lot starting next week. Okay. So tensor also can have gradient of tensor. So when you apply gradient of a tensor for a second order tensor, it will produce a third order tensor. So gradient basically increases the order of tensor. So from scalar, if you apply gradient, it will become vector. If you apply gradient on vector, it will become second order tensor and so on. So for a third order tensor, dia punya tu pengiraan dia semakin pening lah. Jadi kita tak tunjuk lah, tak ada keluar lah. Okay. So another application of del operator is the divergence. Okay. So divergence of a vector field produce a scalar. So just now it's del of f. Okay. You basically del f without any operation. So here, if you have del dot product, okay, so this is dot product of f. So when you dot product del with a vector. So when you dot product, so you apply the dot product concept that you have learned. So you just get a scalar value. Okay, so del x1 e1 dot with f1 e1 plus del x2 e2 dot with f2 f2 e2, and lastly del x3 e3 dot with f3 e3. So dot, you just multiply element by element, okay? But for regular multiplication, you multiply every element, okay? So when you dot a product, of a del operator with a vector, you basically reduce the order, okay? So from vector becomes scalar. So if you dot with a tensor, it will become vector. So let's look at this example. So given a vector f, find the divergence. Okay, so find the divergence del dot f. So let's rewrite the formula. Okay, so you just add up all of them together. So firstly, del f del x, del of the first vector of f, first component of vector. So del f1 over del x. Here you treat y square as a constant, so you get y squared, plus del f2 del y. So here f2, you differentiate about y with respect to y. So 2 becomes a constant. Only y is the variable. There is no y here, so you plus 0. And lastly, differentiate f3 with respect to z. This is f3. So you have 4, a constant, minus y a constant, times z squared. So you only have minus yz squared. Differentiate this, you get minus 2yz. Okay. So differentiate with respect to z. So divergence becomes y squared minus 2yz. Okay, so you can try this later. Okay, so if you apply divergence of a tensor, it will produce a vector. Okay, so this is the formula. Okay, dia terlalu panjang. So because it is too long, jaranglah tanya. Kalau tanya pun formula ni boleh dicari dalam nota. Okay, so another application of del operator is the curl. Curl of a vector is defined as del cross f. So just now it's a dot product. Now we can apply cross product between del operator and f. So cross product, basically you just use determinant. Okay, ada example kot. Okay, so for example, if you want to find a curl of a vector field, so vector field A equals 3yz plus 2xz plus 5xy. So you apply curl of A using this determinant. Okay, so ijk del x del y del z ax ay az, and then just substitute and then find the determinant. Okay, so this is finding the determinant. So for example, the first part of the determinant is I times cross multiply this del y 5xy minus del z 2xz. And so on. Okay, so this example, you get the answer down below. So just be careful when you want to calculate this. So basically, curl, when you want to calculate curl, the application is not as many as del f or del dot f, gradient and divergence. The application of curl is not as much as these two. Okay, so um, tak keluar sangat lah soalan curl. So another application of del is Laplacian. Okay, so if you still remember Laplace transform ke apa ke, I think it is related. Okay, with Laplacian. I'm not sure, but I think it's related. So del square f becomes del of del dot f minus del cross f. Okay, so this is pengiraan dia panjang lagi lah. So tak ada example, tak keluar exam. Okay, so why we learn about divergence del operator? Because there is a theorem. There are theorems in using this del. Okay, so one of the theorem is called the divergence theorem. Okay, so divergence theorem basically relates the flux of a vector field through a closed surface to the divergence of the vector field in the volume enclosed. So sometimes kita nak cari flux, okay? Mungkin belajar dalam fluid dynamics ke, dalam CFD ke. Let's say if you have this box, ada closed surface, permukaan yang tertutup, okay? Closed surface, and then you have a vector going out from that surface or going out from this box. Maybe vector tu keluar sini, keluar sini, keluar sini. So you can think of like a sponge. When you have a sponge filled with water, when you press the sponge, then fluid will flow out from the sponge. Okay, so it's like that concept. Okay, so when you press that sponge, fluid will go out. Okay, so the fluid going out is the flux of fluid. Okay, flux tu macam pergerakan, okay? Pergerakan fluid tu. So to calculate that motion or calculate the movement of flux, we can use divergence theorem. Okay, so divergence theorem basically relates the integration 3 kali, integrate the volume 3 times of divergence of f equals integrate the surface of f dot n ds. Okay, so this is the flux. So to calculate this is very difficult because you have to calculate through all surface. Okay, so because you probably never learn about this, so to calculate this is very difficult if you use by hand. Okay, you need to calculate many times to get the flux. Basically, you need to calculate the flux of vector going through this surface, and then you add up all of them. So if you have 6 surface, then you have to calculate 6 times. But if you apply divergence theorem, you just need to calculate the divergence of f and then integrate the divergence 3 times. Okay, so what it means by integrate 3 times, we will look at this example. Okay, so let's say evaluate this flux. Okay, evaluate the flux of this vector from the surface of a sphere. So to calculate this, you need to calculate, you need to determine the sphere punya surface macam mana, which is quite very difficult. Okay, so we could parameterize the surface and evaluate the surface integral. Okay, so you can use this method, but it is a tedious method. Pengiraan dia panjang. So to make it the calculation much faster, you can use divergence theorem. So we know that the divergence theorem the flux equals integrate 3 times of divergence of f. So firstly, we need to find the divergence of f. So divergence of f, so this is f. So divergence of f you get del x 3x plus del y 2y 0. So here differentiate with respect to x, you get 3. Here you get 2. Here you get 0. So you end up with 5. And then applying this integration dv, okay, integration. So you integrate 3 times about 5 times dv. So here you can keluarkan 5 ni because it's a constant. Factorize 5. So you get 5 integrate 3 times of v. So when you integrate 3 times of v, so when you have this term, this is basically you calculate the volume. Okay, calculate volume of the things that you are under investigation. So in this case, it's a sphere. So the volume of sphere. So this is the radius of sphere. So volume of sphere is 4/3 pi r cube. So you get 4/3 pi radius squared. Okay, this is radius squared. Sorry, radius the 3. So you get 936 pi. Okay, and then times pi, you get 180 pi. Okay, so this is one example how to use divergence theorem. Okay, ada example lagi tak? Macam tak ada je. Okay, there is one more example here. So let's say if you have this f, and then surface is a box. Okay, so you want to compute the flux of f through the box. Okay, so to compute this is difficult if you use integrate 2 times here. So you can apply divergence theorem. Okay, so firstly, find the divergence of f. So divergence of f. So you get del f1 del x plus del f2 del y plus del f3 del z. So let's look at f1 over del x. So this is f1 and differentiate about x with respect to x. So here we have 3x plus z power of 77. So you treat other variable as constant. So z 77 a constant. So you can, when you differentiate, you get 0. So here you get only 3x. Okay, del f2 del y. So this is f2. So if you look at f2, you have y squared. So you can differentiate this. You get 2y minus sine x squared times z. So these are constant because you only differentiate y. So x and z are constant. So this becomes 0 when you differentiate with respect to y. And then lastly, del f3 del z. So you look at f3. So here you have x times z. So differentiate this. You treat x as a constant. So you get x. Okay. And then lastly, plus y e power of x power of 5. So all of these are constant because there is no z here. So differentiate a constant, you get 0. So you end up the divergence of f 3 plus 2y plus z plus x. Okay, so this is the divergence of f. Okay, then you want to integrate the divergence of f 3 times. in a volume of cube. Okay, so this is the volume of cube. So what you can do is first you substitute the value of divergence of f. Okay, so dv here will become dx, dy, dz. Okay, so meaning that you differentiate them 3 times. Okay, integrate 3 times, integrate x and then y and then z. So firstly we start with x. So the range here must be the range of x. Okay, so the range of x is from 0 until 1, and then followed by y. So the range of y is 0 until 3, and then lastly the range of z. The range of z from 0 until 2. So you have to integrate this one by one. Okay, so firstly integrate this part here. So that's how basically how to do the triple integral. Okay, so you integrate this part here. So integrate with x. So you end up 3x plus 2yx plus x squared over 2, and then calculate from range 1 to 0. So you end up with 3 plus 2y plus 1/2, and then substitute minus x equals 0. Okay, so you get all 0. Okay, so you end up with this. But in this example here, it start with del z. Okay, so they integrate z dulu. So if you integrate z dulu, then maybe we look at this example easier. Okay, so if you integrate z, then this equation becomes 3z plus 2yz plus xz, and then calculate from range of z. So you end up with 6 plus 4y plus 2x, and then minus 0. So all of z are 0, you get 0. So these are the answer for the first integration. Okay, so similar. And then you repeat the process, integrate with y pula. So if you integrate with y, you get 6y plus 4y squared over 2 plus 2xy from 3 to 0, and then substitute, you get 18 plus 18 plus 6. Okay, so you get this 6x, sorry. And then lastly, you integrate with respect to x. Okay, so here you get 36x plus 6x squared over 2. Calculate from 0 to 1. So you end up with 36 minus 6 over 2, 3 plus, sorry. So you get 39. Okay, so you can try integrate this later. Maybe if you want to try integrate x first and then y and then z. Okay, so if you integrate x first, you get this, and then integrate this with respect to y pula. Okay, try do this. Maybe we will discuss next week how to perform starting with y and then z. Okay, see the answer will be the same, 39. Okay, and there's another theorem, we call it Stokes theorem. So Stokes theorem relates the integral of the curl of a vector over a surface to the line integral of the vector field bounded by the surface. So this is another theorem yang kalau nak kira manually, if you want to calculate this, you have to consider the whole line, okay, which is very difficult. So we use the curl of f. So this is just example, tapi dalam exam tak ada, tak keluar, okay, sebab pengiraan dia sangat pelik lah, okay. So I want you to try this exercise of divergence theorem. So try this exercise and we will discuss next week how to calculate this. Okay, so try this and make sure you understand divergence theorem. So the most important part about this lecture is divergence theorem and also the concept of divergence. Okay, so I want gradient of vector and also divergence of vector. So when it involves tensor, the calculation is much difficult. So tak ada keluar exam insyaAllah. So yang keluar adalah selalunya how to calculate gradient of scalar, because this is later on in starting next week we will use a lot of this triangle symbol here, the del, and also gradient of vector and divergence of vector. We will encounter this quite a lot of time throughout the rest of the lectures. Okay, so that's it for today. Any question? Okay, so if you have no question, as I said, I want you to try exercise number 4, and then we will discuss next week and try understand the del operation, because we will use a lot later. Okay? I hope you understand this del operation, how to perform the del operation. So that's it for today. See you next week, inshallah. Assalamualaikum. Bye-bye.
Thank you, sir.
Salam, Doctor. Thank you, sir.